So in 2.3, we're talking about GCF factoring. So GCF stands for greatest common factors. The definition of greatest common factors is the greatest number that is a factor of two or more numbers. So let's do an example. So for example 1, we have 45, 81, and 117. So we need to make a list of factors for each of these numbers. So for 45, you can use your calculator to find your factors, but we would get 1 times 45, 3 times 15, and 5 times 9. For 81, we get 1 times 81, 3 times 27, and 9 times 9. And then for 17, 1 times 117, 3 times 39, and 9 times 13. So if we're looking at these, let's look at what factors do they all have in common. Well, they all have a 1, they all have a 3, and they all have a 9. So those are the factors they have in common, but we want to find the greatest common factor. So the greatest one would be 9, right? That's the biggest number that they all have in common. So our GCF, for example number 1, is 9. Okay, let's look at example number 2. So we have 24x cubed, 56x to the 7th, 4x to the 8th, and 12x squared. So let's just look at the numbers for a second, and then we'll come back to the x's. For 4, what are factors of 4? Well, we could do 1 times 4 and 2 times 2. And those are our only factors of 4. So that means if we're looking for a greatest common factor, every single one of these numbers has to have a factor in common. So 4 only has 1, 2, and 4. So that means when we check our other numbers, all we need to do is check 1, 2, and 4, because they all have to have factors in common. So for 24, we could do 1 times 24, 2 times 12, 4 times 6. You could also do 3 times 8 technically, but since 4 doesn't have 3 or an 8, we don't need to worry about that one. For 56, again, we're going to check 1, 2, and 4. So 1 times 56, 2 times 28, and 4 times 14. And again, you could do 7 times 8. However, 4 doesn't have 7 or 8 as a factor, so we don't need to worry about those. And then lastly, we have 12. So we could do 1 times 12, 2 times 6, or 4 times 3. So if we're trying to find our greatest common factor, they all have a 1, 2, and 4. So 4 would be our greatest common factor. So part of our GCF, for example, 2 is 4. But now we need to think about the x's. Well, 4 has x to the 8th, right? So that means we're doing x times itself 8 times. 24 is x cubed, so that means we're multiplying by x by itself 3 times. 56 is to the 7th, so that's 7 times. And then 12 has x squared, so that's twice. So we want to figure out how many x's they all have in common. Well, they each have at least 2 x's, right? So we could pull out an x squared from each of them. We wouldn't want to pick x cubed because our 12 only has 2. It doesn't have 3 x's. So our GCF is going to be our lowest number, so the 2 x's. So our GCF for example 2 is 4x squared. Okay, next we want to talk about what does it mean to factor. To factor is the process of finding factors It's kind of like the opposite of expanding. So if we were trying to find factors, to expand, if you had something like 3 times x plus 4, you would expand that by multiplying it out and getting 3x plus 12. Well, factoring is going the opposite way. So it's starting with 3x plus 12 and going to 3 times x plus 4, finding two things that multiply to our expression. Okay, so we're going to do some examples where we factor out the greatest common factor. So for example number 3, we have 15x cubed minus 9x to the 5th y. So we need to find the greatest common factor between 15 and 9. Well, just by looking at it, we can kind of tell it's going to be 3, right? 3 goes into 15 and 9. If you can't tell by looking, you can always make your table. We have 1 times 15 and 3 times 5, and then 1 times 9 and 3 times 3. So 3 is the greatest number that goes into both of those. With our x's, we have x cubed and x to the 5th. So our greatest common factor, the thing they have in common, is x cubed, right? They both have at least 3 x's. And then only the 9x to the 5th y has a y, so we can't pull out a y because they don't both have a y in common. So now, since we're factoring, we need to figure out what's left when we pull out that 3x cubed so that we can find our two factors that multiply to the 15x cubed minus 9x to the 5th y. So we do that by dividing, right? The opposite of multiplying is dividing. So to find our factors, we're going to divide. So we're going to do 15x cubed, and we're going to divide by our greatest common factor, 3x cubed. Well, x cubed divided by x cubed, those cancel out to be 1. And then 15 divided by 3 is 5. And then negative 9x to the 5th y. That's going to be, again, divided by 3x cubed. Negative 9 divided by 3 is going to be negative 3. X to the 5th divided by x cubed. Remember our exponent rules. When we're dividing and they have the same base, we can subtract the exponents. So 5 minus 3 is going to give us x squared. And then we're still going to have that y because we don't have anything to divide the y with on the bottom. So this is your factored form of example number 3. And if you notice when you're looking at this, if you were to multiply this back out, multiply the 3x cubed into each of these, you should get what you started with in example 3, the 15x cubed minus 9x to the 5th y.